Hello everyone, hope you're good. Today we're going to talk about chapter 5 section 2, electron configuration and the periodic table. Actually there is a big relation between electron configuration and periodic table. So this section is all about that relation. Okay, the first relation is length of period. Basha. When you say length of period, we mean number of electrons in a period. Look at here. We have 7 periods. In each period, there are elements. In the first period, there are 2 elements, hydrogen and helium. Okay? Second, there are 8, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. There are 8 elements. Pasha? So third 8, fourth 18, fifth 18, and 32. Pasha. We know this. But here, what we want to talk about, the relation between the number of elements in a period, we mean length of period, and electron configuration. Guys, the hydrogen and helium, their last electron is 1s. Together, they fill 1s. Basha, look at this periodic table. First period, this is hydrogen. Here, it must be 1s again. The hydrogen is 1s1, and the helium is 1s2. So, first period, just 1s is going to be filled. So 1s when it's filled can hold maximum up to 2. So there are 2 electrons. So there's a similarity between number of electrons in the sublevel and the number of elements in that period. When is 1s filled can hold maximum 2 electrons. 2 electrons means there are 2 elements in that period. So there's a relation. Look at the second one. There are 8 elements. Basha. Lithium here, its last electron is in 2s. After helium, lithium comes. After 1s, 2s comes. It's going to be 2s1, then 2s2 for beryllium. So then for boron, the electron enters 2p1. Then in neon is going to be 2p6. So in the second energy level, 2s and 2p, they're going to be filled. And we can say the elements in this period, their last electron is where in 2s and 2p. Bash. In this period, 2s and 2p, they're going to be filled. We know p can fill by 6 electrons. So 2 plus 6, 8. So there are 8 elements. There's a similarity between the sublevels in order of filling. The sublevels, they're going to be filled in a period and number of elements in that period. So this is, you can do it for others. So here for 4th energy level, 4s, 3d, 4p, they're going to be filled. P can hold 6, d10, s2 together. The number of electrons in that period, so equals 18. So there are 18 elements in that period. Okay, this is the relation between length of period and electron configuration. Bash. Determine blocks as PDF. What are blocks? In the periodic table is divided into 4 blocks as PDF. For example, you see that group 1, group 2, helium, they are in S block. Why? Because their last electron, these elements, their last electron is where is in S sublevel. So look, blocks can be determined by what? Electrons in the outermost shell sublevel. It means in which sublevel is the last electron, the element is in that block. Okay? See, so the highest energy sublevel is what? Is the block. For example, look at this nitrogen. In the exam, I give you an electron configuration and you need to know the element is in which block. Bash. The electron configuration ends with P, means that the last electron is in P. So we say that nitrogen is in P block because the last its electron enters P sublevel. Basha? Got. So group 13 to 18, except helium, these elements, their last electron enters P sublevel. Basha? And here, group 3 to 12, Basha, these elements, their last electron is in D sublevel. Group 1, group 2, and helium, Basha, helium, these elements are called S block elements because their last electron is where is in S sublevel. Basha? Okay, for example, group 1, their last electron is S, and the last S contains only one electron. S2 means 2 electrons in last shell. Let's continue. We're going to talk about first the S block elements. S block elements are group 1, group 2, and helium element. Basha? Group 1 elements. Group 1 elements, the metals of group 1 we can say, lithium, sodium, potassium, rubidium, cesium, francium. These are elements of group 1, and the elements in red color are important. You need to know that they are metals. Basha? We call group 1 metals alkali metals. They are metals. We call them alkali. Next slide, we're going to explain why we call them alkali metals. Basha? They have silvery color. Look at here, alkali metals. They are all solid at room temperature. Look, their color is silvery color. Basha? This is here is important too. S block elements are chemically reactive metals. Basha, group 1, group 2, they are reactive metals. But the group 1 metals, alkali metals, they are more reactive than those of group 2. They are more reactive than group 2. Actually, group 1, group 2, they are called reactive metals, but group 1, they are more reactive than group 2. Okay? And the outermost energy level in an atom of group 1 element contains a single electron which is in S sublevel. Here is important that group 1 metals, they have only one valence electron in their outermost shell. Basha, there is only one electron in the last shell of these elements. Where is this element? This electron is where it's in S sublevel. Basha, it's in last S sublevel. So their group configuration. What does mean their group configuration? How can we recognize their electron configuration? If I give you an electron configuration in the exam, how do you know this is electron configuration of an element in group 1? So this is a group configuration which is NS1 group configuration. What does it mean? Look at lithium. Lithium, which is in second row, means second period. The electron configuration is 1s2, 2s2, 2s1, sorry, 1s2, 2s1, Basha. It ends with S because it's in S block. That's why we say it's S block. And which is, this is in second period. We're going to explain why. But it has only one electron in last S. When an electron configuration ends with S sublevel and contains only one electron, we say this element, it's where it's in first group. And also we know we can recognize by NS1. Look, 3s1 for sodium, potassium 4s1. It ends with S, but this number changes before S. That's why we give N. N is the main energy level, Basha, here. So N, it tells us the period, Basha. So if I give you an electron configuration, how do I know this element is in which period? Look at the highest occupied energy level, Basha. The highest occupied energy level here is 2, or we can say the number before last S is the number of period. Element. If I don't know, this is lithium. This is electron configuration of lithium. How do I know this element is in which period and in which group? Look at the last, which is in S sublevel. S sublevel can be group 1 or group 2. S contains only one electron. We say it's group 1. And it ends with S, which is block S. And the number before last S is 2. So it's in second period. Basha? This is how we can recognize the electron configuration of group 1. Okay. There another characteristic of group 1. They are soft enough to cut with a knife. We can cut them with knife. We learn in chapter 1 section 3. And they are, because they are so reactive, alkali metals are not found in nature as free elements. We find them in compounds. We don't have a free element of group 1 in nature. So we find them in compounds. For example, we want to get sodium element, we can get from this compound, table salt. We are going to decompose NaCl and we get free sodium element. Basha? Because of their extreme reactivity, and they react with oxygen, with moisture, with water vapor, alkali metals, we're going to store them in what? In kerosene or oil. Look at this picture. We have potassium, which is a metal of group 1. Look, it has stored in a special liquid, which is kerosene, or we can store it in what? In look, it must be stored in kerosene or oil. Basha? Potassium here is stored in kerosene. Basha. They react strongly with water to produce hydrogen gas and aqueous solution of substance known as alkalis. That's why we call them alkali metals, because they produce an aqueous solution which is called alkalis. Look, this is an example of group 1, sodium. Sodium react with H2O, then we get what? An aqueous solution, which is base. We call alkalis. Can be lithium, it will be lithium hydroxide and hydrogen gas. Basha? This is when they react with water, they produce alkalis and hydrogen gas. Basha. As we move down the group, the melting point decreases. The elements melt at progressively low temperatures. Means as we go down the group regularly, the melting point decreases. Means we're going to need less temperature to melt a group 1 metal, which are solid. Basha? Group 2, we talked about group 1. We're going to talk about group 2, group 1, group 2. They are in S block. These elements are called S block elements. Bash. Group 2, they are beryllium, magnesium, calcium, strontium, barium, radium. The elements in green color, they're important. You need to know them. We call them alkaline earth metals because they're oxides and hydroxides compounds. We can find them in earth crust. Basha? This is important to know. We call them alkaline earth metal. And they contain a pair of electrons in their outermost S sublevel. They contain, or we can say they have 2 valence electrons in their outermost shell. Okay? And where are these 2 electrons? They are in S sublevel. So we can give a group configuration for group 2 NS2. Basha, their electron configuration ends with NS2. Look at here, beryllium 1s2, 2s2. Basha, it ends with S, contains 2 electrons. Exactly, we know beryllium, it's where? It's in group 2. And for period, we look at the highest occupied energy level. We have two shells. Second shell is going to be the last shell. Last shell is called highest occupied energy level. So the highest occupied energy level is 2. Or we can say the number before last S is the number of period. Look, they all end with S and S2. N is the what? Energy level, main energy level, or number of period, the number before last S, 5S, 6S, 7S. Okay? Group 2 metals, they are harder, denser, stronger than the alkaline metals. Basha? They are stronger, harder, and they have higher melting point than group 1. Generally, they have higher melting point than group 1. This is the difference between group 1 and group 2. And also, they are, as we said, they are less reactive than the alkaline metals. Alkaline metals mean group 1. And the alkaline earth metal, like group 1, they are too reactive to be found in nature as free elements. Okay? If we have group 1 metals, group 2, as free elements in nature, they react with oxygen. And group 1, they are very reactive. They react with oxygen and oxygen and water. Okay? We will lose them. So that's why we stored them in kerosene, but group 2 doesn't need, because they don't react quickly. They don't form compounds. They don't combine with other substances to form compounds quickly. Okay? Hydrogen and helium. Hydrogen, we know that we have placed above group 1. But do you know, or we can say it's group 1, but its property is not like any other group. So since they have placed above group 1, just because we know hydrogen has only one valence electron, 1s1, it's the electron configuration of hydrogen. Its group configuration is like group 1, isn't it? Has only one electron in last s. But while we have placed above group 1, it doesn't share properties, similar properties with group 1. There's a reason, because look, it's located above group 1 element because it has N as group configuration, means it has group configuration like group 1. It has only one valence electron, its outermost shell. That's why we have placed above group 1. But actually hydrogen, it's non-metal, it's not metal. And also, why we have not placed in the part of non-metals right side? Because its property is not like other non-metals too. Okay? We have helium, Basha. Helium is a non-metal, Basha. Helium, its electron configuration is 1s2, Basha. Its group configuration is not like group 2. Group 2 group configuration is NS2. It has 2 electrons in the last shell, like group 2. It has 2 electrons in the last s. So why we have not placed above group 2? Because its highest occupied energy level is filled by 2 electrons. Its last shell is filled. When its last shell is filled, it gives helium special stability, exhibiting what? The unreactive nature of group 18, because its property is like group 18. It's stable like group 18. Okay, that's why we have not placed group 2. And you might say, why group 2, they are not reactive? They have 2 electrons in the last, why they are unreactive, group 2? Because the group 2 elements, they have 2 electrons in the last shell. Because group 2 elements, they start from second period. Okay? Beryllium. Look at here. Beryllium, when we write, it starts 1s2, 2s2, bash. For helium, we have only one s in the first energy level, and it's filled. But for beryllium, Basha, for beryllium here, we know that in the second energy level, we have 2p as well. 2p. And second energy level fills by 8 electrons. But for these elements of second group, they have only 2 electrons, and the p sublevel contains it's empty, doesn't contain any electron. That's why group 2, they are not stable, because they have only 2 electrons in their outermost shell. But helium, we know group 1 fills only by 2 electrons. That's why helium is stable, and other elements of group 2, they are not stable. Okay. Look, sample problem. It says, without looking at the periodic table, identify group, period, and block for this element. This is the electron configuration of an element. Basha? It's not important the name of the element here. We want to know this element is in which block, in which period, in which group. Okay? So, how do I know? The last electron is in S. So block, this element is in S block. Bash. Then I want to know the period. The period means what? In a group configuration, Basha, period means the highest occupied energy level, or the number before last S. The number before last S equals what? 6. So this element is in 6th period. So in which group? In which group? For group, we need to know the group configuration. Group configuration of group 1 equals what? NS1. Group 2, so it's in S block. It must be group 1, group 2, or helium. This is NS2. Basha. So 6s2 is like which one? It's like group 2. It has 2 electrons in the last S. So this element, it's in second group. Basha. S block, period 6, and group 2. Basha. If I ask in the exam 1s2, this element, it's in which block? You directly say this element, it's in S. And you say period, the number before last S period is 1. What about group? So this is not like group 2 group configuration? Yes, so it's in group 2, right? But actually not. Why? Because this is electron configuration of helium. So helium, it's in which group? It's in group 18. Basha, this is exception. Okay? Know this. We have another type of question, which is what? The question gives you the group and period, and it tells you write the electron configuration. How do I know? The element is in group 1. Group 1 group configuration, you must write group configuration NS1. It means the electron configuration ends with NS1. N equals what? Look, in group configuration, N equals number of period. So period is third period. So N equals what? N equals 3. Asha? 3. S dash 1. So the electron configuration ends with 3s1. So you're going to start writing electron configuration from 1s. 1s, 2. 2s, 2. 2p, 6. Then 3s, 1. Okay? This is how we write electron configuration if I give you period and group. Okay. We have these questions. You can check by yourself. It's easy. Look at this one. This is S block, group 1, because it has only 1 electron in last S, and the number before last S is 5, means this element is in 4th period. Okay. D block elements, group 13 to 12. D sublevel appear when n equals 3. We learned that we don't have 1s to, we don't have 1d to d, because d starts in 3rd energy level. But we know that for s, we fill before 3d, because 3d is slightly high in energy than 4s sublevel. So these are filled in order 4s, then 3d. But we have exceptions. Sometimes one electron here goes to d sublevel. We learned. Okay, d block elements, group 13, 3 to 12. 3 to 12 group elements are called d block elements. D block elements, they are metals. Basha, we call them transition elements or transition metals. They are good conductors of electricity. They have high luster, they are shiny, and actually they are less reactive than S block, alkali metals and alkaline earth metal. If we order the reactivity of metals, the most reactive metals are group 1, alkali metals, then alkaline earth metal or F block metals. F block metal akançin, lanthanide and actinides. Basha, lanthanide and actinides, they are in F block. They are all metals. We learn their reactivity is like alkaline earth metal. Then transition metals. The less reactive metals, they are transition metals. Okay? And their group configuration is NS 0 to 2, N minus 1, D1 to 10. So if I give you an electron configuration, how do you know this is an electron configuration of D block, group 3 to 12? So you can recognize like that. It says N and S can hold 0 to 2. The number before D equals N minus 1. For example, if N equals 4, so this is going to be 4s, and here is going to be 4 minus 1 is going to be 3d, like 4s, 3d. Basha? And the number of electrons in S can be 0, 1, or 2. Basha? 0 to 2. Here D can be 1 to 10. So why it's like that? Because we're writing generally for 10th groups. 10 groups, so we can't write, like it's going to be difficult to write group configuration for each group. Instead, we are going to write a group configuration for all groups. It's going to be like that. When it's going to be 0, guys, we have palladium here. Sometimes it has 5s 0, 2 electrons transfers to what? To D. Basha? Is like that. Palladium. That's why for this element S contains 0. That's why it's here written 0 to 2. Okay? And D can be 1 to 10. For this element, for palladium, we have only 8 electrons in D. Okay, that's group configuration. I think later you will understand better. And palladium, platinum, and gold, so unreactive, and they don't easily form compounds existing in nature as free elements. These elements actually, we know that D block elements, they are unreactive, they are less reactive, but these elements, they are very unreactive. Okay? Indicating group period for D block. So if I give you an electron configuration, if I tell you indicate the block, the period, the group for the following, how do you write for D block? First of all, you must know this is the electron configuration of which block. So look at the last sublevel. So the electron, the highest energy sublevel, or here you can say the last sublevel that enters electron. So block is D. Basha? And period. For period, look at the highest occupied energy level. Here is, we have how many shells? There are 4 shells. So the last shell, the 4th one, will be highest occupied energy level, and the block equals the highest occupied energy level. Or you can look at the number before last S. Always it works. Period 4. What about group? Guys, for group, for D block equals what? The number of electrons in last S, last D. How many electrons are in last S? 2. D 5. 2 plus 5, 7. So just for D block, number of group equals a number of electrons in last S, last D. 2 plus 5, 7. Look at this one. Block, the last sublevel is D, block D. What about period? Period is number before last S, highest occupied energy level, 5. What about group? Group equals number of electrons in last S, last D. 2 plus 10 equals 12. So this element is in group 12. Okay? Another type of question, I give group and period, write electron configuration. Okay. Here, what you must think first, this element is in which block? It's S, P, D, F. So group 5, we know that group 3 to 12, Basha, group 3 to 12 is what? Is D block. Basha. So the group 5 is in D block. D block, first you must write the group configuration. NS and minus 1D. S can hold 0 to 2, we don't know. Depends on the element, and 1 to 10. Here, N equals what? N equals the period number. Period number is 4, so N equals what? N equals 4. Bash. Then, when N equals 4, Basha, this is N equals 4. N minus 1 means 4 minus 1. So the number of sublevel, Basha, which sublevel is that? Equals N minus 1. So it's going to be what? It's going to be 3. 3 D, Basha. How many electrons do we have in S and D? Can be 0 to 2, 1 to 10. If there are exceptions, can be 0 and 1. But always there are 2 electrons because we fill S and D. So equal number of electrons in last S, last D, we said equals number of group. Now group is given. So group number means number of electrons in last S, last D. So 2 electrons enter what? S, and how many electrons left? 3. Basha. So 4s2, 3d, 3. Okay? Then what you need to do, write the whole electron configuration. Start from 1s until you reach 4s. Basha, like that. So this one, group 4, 5th period. Group 4 is in D block. D block NS, N minus 1, D. Basha. Here group 4 means there are 4 electrons in last S, last D. So it's going to be S2 and D2. What about N? N equals 5. And the number before here is going to 5 minus 1 equals 4. So this is the actual, this is called outer electron configuration. If I tell you write outer electron configuration, you're just going to write 5s2, 4d2. But if I tell you write the electron configuration, you must write the whole electron configuration like this. Okay? Let's continue. Here we have this one. Just I want to tell you, here in the book is written 4d5, then 5s2. The book uses that way. We said we don't use that way. First we write 5s1. Both of them are correct, but if you write like the book, I think you will get confused. Okay. The last sublevel that contains electron is D. So this element is in D block. The highest occupied energy level is 5, or the number before last is 5. When it's D block, number of group equals number of electron in last S, last D. 5 plus 1 equals what? 6. So this element in 6th period. So Also, we have this element. Don't forget, write 4s2, then 3d8. The p block elements group 13 to 18 Basha, and the p block elements, they are where in group 13 to 18. Look at here, except helium Basha. We know that helium it's in where? It's these elements, they are in p block, and helium it's where it's in s block Basha. We have something else. S block elements together with p block elements are called main group elements Basha. The elements of group 1, group 2, 13 to 18, or we can say p block with what? S block elements. They are where? They are called main group elements. So D block elements, we don't call them what? Main group elements. Guys, look, this is in P block we have non-metal, we have metalloid, we have metals too. Okay, so we're going to talk about each of them. So first we start from we know we talked about group 18. They are unreactive non-metals, they are noble gases, but the helium here is not in P block. Okay, but let's talk about group 17. Group 17 are called halogens. Halo means table salt, gene means forms, table salt forms. Why? Let's explain. The elements of group 17, fluorine, chlorine, bromine, iodine, and astatine, are known as the halogens. The elements in green color, they're important. Fluorine, chlorine, bromine, iodine, they are the most what? The most reactive nonmetals. They are nonmetals. Beyond the nonmetals, the most reactive nonmetals are halogens or group 17. They are strongly react with most metals, Basha, to form a type of a compound known as salts. That's why we call them halogens, Basha, as we said. Like NaCl, Na is a metal of group 1, chlorine is a nonmetal of group 17, halogen. Halogen is a metal, it forms salt. Okay, and fluorine, chlorine are gases at room temperature. Bromine is a reddish liquid, and iodine is a dark purple solid. We have astatine, synthetic element, Basha, artificial, which is not very important, you to know it, as we have only very small quantities, small amount of astatine in laboratories. Okay, so just know fluorine, bromine, chlorine, and iodine. Okay, metalloids. All the metalloids, where are they? Look at here. All the metalloids are where they are in P block. We learned that they are semiconductors elements. They are located between metals and non-metals. These are metals, and these are metals. These are non-metals. Non-metals, they are between them. Okay. I think we learned about their characteristics. They are all solid. And look, bromine and silicon, try to know they are metalloids, and try to know their symbol, which is B capital, and silicon is I. Okay. Metals of P block. In all blocks, there are metals. P block metals, they are harder, denser than the S block. It means group 1, group 2, but they are softer, less dense than the D block. Look at here, this one, here it explains this paragraph. Look, transition metals, they are the hardest metals, dense metals, and then P block metals. P block metals, they are they are harder, denser than the S block. This is S block. Alkaline, but alkaline earth metal group 1, they are harder, denser than alkaline metals. Alkaline metals, they are the less dense metals. The hardest metals, they are what? Transition metals. Okay. Indicating period and group for P block. The group configuration is NS2NP 1 to 6. This is group configuration that we can recognize them. Okay, look at this electron configuration. 1s2, 2s2, 2p3 indicate block group period for the following. Here we know block is easy. The last sublevel that contains electron is what? Is p. Basha? Or just look at the electron configuration. The last one is p, so block p. What about period? Period, the number before last s or last p. In the p block, guys, the number, look, we have two shells. The second shell is called the last shell. 2s, 2p, they are in the second shell. So the last shell is 2. And or we can say the number before last s or p is correct for p block, but for others doesn't work. So the number before last s is 2. Basha, period 2. Always choose that number. Okay. And the group, this is important. For p block, we know that this element is in p block. So how do we indicate the group? Group equals the number of electron in last s, last p plus 10. Basha, plus 10. Look. We have how many electrons in last S? 2. Last P? 3. 2 plus 3? 5. Plus 10 equals what? Equals 15. So this element is where it's in group 15. Okay, look at this one. So this is in block P, Basha. The period equals 4, the number before last S, highest occupied energy level. And the group equals number of electrons in last S, last P, 2 plus 6, then plus 10. This is rule, number of electrons in last S, last P, plus 10. 6 plus 2, 8. 8 plus 10, 18. Look, the element is where it's in group 18. Okay, we're going to use that sentence. Next slide. So if I give group and period, how do you know electrons in last S, last P equals group number minus 10? Look, this is group is given and the period. Write electron configuration. So this is group 13, third period. So this is in P block. P block equals NS 2. This is group configuration, and P 1, 2, 6. Basha. N equals 3. Basha. N equals number of period. 3. So 3S, 3P. Okay. Then, how many total number of electron in S and P? Look, group is given. We know number of electron in S and P plus 10 equals group number. Now group equals 13. So number of electron in last S, last P equals group number minus what? Minus 10. So 13 minus 10 equals 3. Number 3 is the number of electron in last S, last P. The rule says always put 2 electron in S. It's not like D block. In D block says NS 0 to 2 because we have exception in D. We said chromium, copper, silver. These are exception in D block. 1 electron from S moves to D, like chromium 4s1 3d5. Okay, you should know these exceptions, you do not get confused. How do you know how many electrons we have in S and for D block? You must count the number of electrons. If it equals the number of electrons for one of these, chromium, copper, silver, just take 1 electron from S to D. Basha, I forgot to talk about in D block. So here for S, we have always 2 electrons, P 1 to 6. How do I know? There are 3 electrons. 2 electrons for S. So how many electrons are left? Only 1. So 3s2, 3p1. Then what you need? Write the whole electron configuration. If I tell you write just outer electron configuration, you'll just write this. That's enough for me. But here is written, write the electron configuration. 3s2, 1s2, 2s2, 2p6, 3s, 3p1. Here, group 17, Basha. Okay. Group 17, fourth period. Here, there is something. Group 17 means P block. P block is NS to NP 1 to 6. Okay, that's nice. N equals 4, 4s 2. Then P equals N means 4P. So group number 17. 17 minus 10, 7. 2 enters, 2 electrons enter S. Then how many electrons going to be left? 5. Okay? Because this is group 17. This is halogen. So you write the whole electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But do you know between 4s, 4p, what do we have? We have 3d. Basha, don't forget this. If I tell you write the outer electron configuration, just write 4s2, 4p6, 4p5. But here it says write the whole electron configuration. You must add 3s, 4s2, 3d10 like this. Let me erase it. This is the group configuration. Basha, 4s, 4s, 2, 4p, 5. But here there is 3d, 10 between 4s2 and 4p5. Don't forget this. Here we have an element in group 14, second period. Group 14 means P block. Second period means 2s, 2p. How many electrons are in last s, last p? Group number minus 10. 14 minus 10, 4. 2 electrons, always put it in s. How many electrons going to be left? Put it in P. So it's going to be 2s2, 2p2, and 1s2. Write the whole electron configuration, 1s2, 2s2, 2p2. Okay? Others also, don't forget to do it by yourself. These are the answers. But sometimes, look at this element. It says, name the element. You need to look at the periodic table. If I ask this question and tell you name the element, I must give you the what? The element. But it says identify as a metal, non-metal, metalloid. But you know that for this one, this is carbon actually. If I tell you this is electron configuration, or write the electron configuration for carbon, we know that carbon, I gave you the periodic table, and you must know that carbon is a non-metal. So that in the exam you say that the element which is carbon is a non-metal. So this is which group? This is group 14. Okay. Okay, let's continue. F block elements, lanthanide and actinides. In the periodic table, F blocks, here they are placed below the periodic table. We learned that because to not the periodic table be wide. Lanthanide, actinides, they are all metals. Their reactivity is like group 2, Basha, group 2 metals. Okay, they are reactive like group 2. And they are between group 3 and 4. They don't have group. Group is not assigned for the period, but here, look at here, lanthanides, they are where? They are in 6th period, actinide in the 7th period. Look at here, this is lanthanide, their original place is here, and actinide in 7th period between the element 88, atomic number 88 to 104, okay? And they don't have group, they fill for F sublevel. Basha means lanthanide, their last electron is in F, but for F sublevel. But here actinides, they fill 5F sublevel, means their last electron is in 5F. And lanthanides are shiny metals. The reactivity is like group 2 alkali metals. Actinide, they are radioactive elements, and their first 4 actinides have been found naturally on Earth. They are natural, but others, the other 10 elements of actinides, they are what? Laboratory made elements. Okay, they're artificial. We don't have them in nature as real. So look at here, indicate block group period for the following. If I give you this electron configuration, you know that it ends with F. It's in F block. What about period? Look at the number before last S, 6th period, and group. It's F block. Group is not assigned. No group. Okay? We have a sample problem. Here, just don't forget to write like that. For A, xenon. 6s1 this is exception of Asha. Why that? We know that S must be filled, but this is exception. For electron configuration of lanthanide actinide, there are many exceptions. Actually, they are not important elements because most of them, they're artificial. We don't have, they are not common element. Okay, this element is in which block? This is in block D, and period, which period? Period 6, because the number before last S, the Hazak number, and the group for D block equals number of electrons last S, last D equals 10. Basha, it says which element is that? Okay, this is group period 6, group 10, I think it is what it's here written, because we need to look at the periodic table. Platinum, it's platinum, Basha, and it tells you, is it metal or non-metal? We know it's D block. D block is what? It's metal, Basha. We have this one. This is in 3rd period, block P, and group equals number of electrons in last S, last P, because P block is P block, plus 10 equals group equals 17. It's group 17. 17s, they are what? They are non-metals, and they are reactive metals. Are they reactive or not? D block for this one is what? It's low reactive. Okay, and it tells you whether element high reactive or low reactivity. This element, this is in P block, period 3, group 2 plus 6 plus 10, group 18. Group 18, they are non-metals, they are unreactive. This one, in the exam, I don't write like that. I write like that for 86S, 2 for F6. Basha, this element is in F block, period 6. The number before last S, group is not assigned. But is it high reactive or low reactive? It's high reactive like group 2 because it's lanthanide. Basha, you can check the others. But here, write 4S, then 3D. These are the answers. And this is the section review. Hope it was useful. Thanks for watching, for listening. And see you next time when we talk about chapter 5, section 3.